Hi there! If you're just starting your journey into the world of computer science, then this video is just for you. Today we will talk about the basics of the hardware with a special focus on binary numbers. Let's get started. Human brain is what helps us to store information, to draw conclusions based on that, and to implement some functionality. On the other hand, our gadgets, our phones, our tablets, computers, and laptops have some sort of intelligence too. They receive, store information, and do calculations with it. Those calculations are done constantly and at a very high speed. So that is the reason why we can watch videos on our phones, why we can text our friends, and do many other things with our gadgets. The CPU is the brain and the heart of our computers. Let's understand how exactly the CPU does these computations, how it stores information and converts it. As weird as it sounds, to understand how computers work, we need to understand the numeric systems. And the numeric system used most commonly by humans is the base 10. It turns out that computers don't understand the decimal system in which we count. The computers count in base 2, and that base 2 consists of only ones and zeros. Transistors in the CPU play the role of switches. One is the presence of the signal, and zero is the absence of the signal, so transistors switch in between them. We can think of these ones and zeros as of boxes, and each of those boxes is called one bit. In these binary systems, we can store not only numbers, but we can store also videos, images, and much more. Let's see how can we convert the language of computers, the binary, into the decimal numbers. First off, we give each box an index, and the index of the first box will be 0. And secondly, we need to understand that for each box we have only two cases, so it's either going to be 1 or it's going to be 0. So as we start calculating, we write 2 to the power of 0 times the digit which is standing in the box. So firstly we write 1 times 2 to the power of 0, then we write 0 times 2 to the power of 1 in this case, and so on. And to calculate the final decimal number, we sum them up together. Congratulations! You did your first step into the world of computer science and converted your first binary number into the decimal. Now let's see how do we convert decimal back into the binary. Converting decimal into binary is even easier because to do this we just need to divide our number by 2. In this case we have 95, and to convert it we divide it by 2, we get 1 in the remainder and 47 in the quotient. We again divide it by 2 till we reach the last one. And in order to get our final binary number, we collect the remainders from bottom to the top. Applying what we have learned so far, we can convert decimal into any other numeric system and vice versa. For example, for the base 4, we can see that for one bit we have only 4 possibilities. It can be 0, 1, 2, or 3. We position the number starting from 0, but in this case, instead of writing 2 to the power of index, we write 4 to the power of index, and again multiply it to the digit which is in the box, and to get the result, we again calculate their sum. Congratulations again! Now you know how to convert numbers into any other numeric system. You probably have noticed that different shades of colors are not written as dark orange or light yellow, for example, but they are written as a code. And that code is hexadecimal, which is another famous numeric system. This system consists of digits, numbers from 0 to 9, and letters from A to F. And A is 10, B is 11, etc. Now time to learn arithmetic operations. Binary addition has a few easy rules. The first rule is that the sum of two zeros is 0, the sum of 1 and 0 is a 1, and the sum of 1 and 1 would be 1 and 0. To calculate the sum, we position the numbers below each other, and as we can see in our case, the second number has more digits than the first number, so add the 0 to the front of the first number, because if we add it to the end, the number will change its value. So we start summing them up from right to the left. And first we can see 1 plus 1 would be 1 and 0. So we write down the 0 and we carry the 1 to the other side. Then again we have 1 and 1, which gives 1 and 0. We write down the 0 and carry the 1 and so on. And in the result we get our final number, which would be 36 in the decimal. Subtraction rules are somewhat similar to the addition, and they are more intuitive. As we have 0 minus 0 as 0, we have that 1 minus 0 would be 1, and 1 minus 1 would be 0. However, we have 0 minus 1 resulting as 1 in the borrow, and we will learn how to deal with this in a moment. Here, we can treat it as to a subtraction with regular decimal numbers because the rules are the same. So we start from the right and we go to the left, and again we get 1 minus 0 resulting in 1, and we repeat this cycle till we reach the end, and our result is 1, 0, 1, and 1. Dealing with borrows is not as scary as it seems. Here we have 1 minus 1 equaling to 0, and we have 0 minus 1, and to calculate this, we need to borrow 1 from the next digit, which is 1. So the next digit of 1 will turn into 0, and our current 0 will turn into 1 and 0. So 1 and 0 minus 1 would result in 1, and as the next one already turned into the 0, we will have 0 minus 0 equal to 0, and in the end we will have 1 minus 1 equals to 0. Multiplication rules have absolutely no difference from the multiplication with decimals. So we will have 0 times 0 equals 0, 0 times 1 equals 0, and 1 times 1 would equal 1. Here we again position our numbers one below another and multiply them one by one. So the first number is 1, and we basically need to copy the first number. Second is 0, so we just write all zeros, and third one is 1, so we again copy the first row. Then we apply our addition rules, and we get from right to the left, we get 1, 1, then again 1, then there are two ones, so we write down the 0, carry the 1 to the other side, and again we write down the 0, carry the 1, write down the 0, carry the 1 again, and we get all zeros and 1 in the end. So 1, 4 zeros, and 3 ones is our answer. Thank you very much for your time and attention. I hope this video was useful, and you will see me again if my computer science instructor assigns me to do a YouTube video again, but probably he won't, so this is the last time you ever see me. Bye bye.